Hello, and welcome to Business Calculus, Analyzing Graphs. Previously, we've discussed the shapes of graphs and the relationship between those shapes and the first and second derivative of the function being represented by that graph. Using this knowledge, we can go in the opposite direction. We can look at a graph of the derivative of a function, f prime, and then try to determine some general properties of the function f. For instance, we can take a graph that looks like this, which is the derivative of a function, and then make a guess as to what the real graph of a function looks like, such as this f of x here. All right. What we'd like to do here is to do our best to make a sketch of the function f based on what its derivative is doing. The first thing that we're going to do is collect as much information as we can from the derivative here. So let's look at what the function is doing on the interval from negative infinity to negative 3. Okay? We see that the function is decreasing because the first derivative is less than 0. Okay? Then, on the interval from negative 3 to positive infinity, we see that the derivative of our function f is always positive. So we see that the function is increasing. There is one point here where it does intersect with the x-axis again, but that's okay. So this tells us that because the function goes from decreasing to increasing at negative 3, that there must be a local min at x equals 3. X equals negative 3, excuse me. So, based on just the small bits of information, we can get a little bit of an idea about what our function f is supposed to look like. Using this, we're going to make our sketch. So, we say f of x down here. We go ahead and draw the y-axis vertically matching up with the graph above. We draw something that achieves some sort of local min at x equals negative 3. We see that the function goes up, and then we know that the function almost stops increasing at x equals 0 because it comes down and touches the axis, but then it recovers and turns out to be okay. We're going to compare this to the actual graph of the function, which I'll put on screen just in a second here. And now we see that we didn't do that bad of a job. The important features, of course, are the local minimum here, which we knew about based on the function switching from decreasing to increasing, and this feature here, which is an inflection point, which we glean from the fact that the function dips down and touches the axis here. And we will discuss inflection points, of course, in more detail as we progress through the information in this chapter. Now what I'd like for you to do is to take this graph of f prime here and then to try to sketch the graph of f based off of this information. So copy this down because it won't be visible on the next screen. All right. Here are some possible choices for your function f. choose the picture that best matches what you believe is f based on the previous f prime. Thank you very much for listening.